It is my great pleasure and privilege to welcome Ioan Muntean once more here at the University of Bucharest. Ioan is not only a dear friend, he's also a former teacher of mine. I remember with great pleasure a class I took as an undergrad with him teaching it, and then he decided to abandon us for the States and go to now he's at Illinois Urbana-Champaign, he's at Texas Rio Grande Valley, and he has been, and I have no doubt will be, a wonderful person and a researcher. So, with that in mind, chain of thought is explanations, decomposability, compressibility, comprehensibility of language, and LLM. Ioan, the title is nearing the full length of the talk, so looking forward to the rest. Thank you, and please take it away. I'm afraid we can't hear you yet. Yeah, he can hear us. I wonder if it's.
I hope now it's working.
Yes. We were wondering if an AI, pulled a trick on you and turn off your mic. So let's hear it. Wonderful.
Yes, I heard what you said, and I'm just saying that if people are doing the math that you've been in my class, we already are labeled as old. But yes, thank you. Yes, it was a great privilege, and I will be back and teach in May for about 2 weeks at the University of Bucharest, right there, probably in one of those rooms. Thank you. Yes, so the title is long, but the words are unfortunately long, and I will explain most of them here. And because I'm presenting this at the very end of the conference, I can kind of piggyback on people's work and definitions and stuff. So I don't have that much of positive thesis here, although I try to be as positive as possible. But I try to entertain here like a little analogy between what we do in science with scientific models and what happens with LLM. So this is the big picture, and I want to use or abuse sometimes these parts of the analogy and to discuss a little bit the speech act. So the argument would say, and this is the 1/3 of the paper, which hopefully will be out soon because I'm interested in publishing it, that some explanation coming from models, scientific models, they qualify as speech acts, and I'm going to work a little bit on that first hypothesis, or let's say premise. Then I will say a little bit more about chains of thought that can be interpreted also as model explanations, right? So I'm going to bring this analogy together. On one side, you have models in science. On the other side, you have LLMs, which are models. And then I will say that there are some chances that some COTs can be interpreted as speech acts based on this analogy. So this is the structure of the talk. And the first part will be, let's see what we can get out of philosophy of science of models, which is a very, very rich literature, as you may have seen. You can think that there are so many types of models there, and you can also question whether they have common features, right? What I'm going to do here is to focus on scientific models of natural phenomena which target a specific phenomenon in the world. And I also want to even more focus and zoom in into the mechanistic models here. But in general, if you remember in philosophy of science, everybody's telling you models are powerful tools of representation. They are representing something, which we call the target system. And they have at least two features, which are predictive and explanation. So they are predictive and they are explanatory. They do explanation. They do have this kind of footwork in explanation. Together with theories and other hypotheses, many other things are explaining. It's not the only one. But in any case, the idea would be scientists do like to work on ensemble of models, and pick the best model based on their powers, either predictive powers or explanatory powers. They are going to you're going to witness here like a competition between different models, right? And because you have at least two standards, predictive, explanatory, and we'll talk about understanding a little bit, there is always a trade-off. Okay, that's the short story that is less controversial, I would say. Okay, so other ideas that I need to use in my argument is explanation and prediction can be decoupled. Don't keep them together. Some models are extremely well in predicting, not explanatory, the other way around. Think about models in quantum physics, which are predictive, but not super explanatory. Some are explanatory, but not predictive. And again, I want to emphasize that I'm focusing more on mechanistic models. Now, causal and mechanistic models are different. Most people will say that mechanistic models are better in explaining than just pure causal models because they have decomposability. Finally, I mentioned that long word. They can be decomposed, can be organized, and they can be also collated together, put together in a composability. So the opposite of decomposability. In cell biology, that's obvious because you see how, let's say, the model of the cell can be composed. It's a model of a tissue and so on. So, or in gene networks, if you are familiar, gene neural networks, in which you can see this combination as being possible. All right, so we have explanation from model, excellent. Now I want to move a little bit in more controversial part because most people who talk about models in science will say that models are descriptive. Of course, this is the point of representation. They represent a target system. It looks like a couple of people, not a couple, let's say 3-4 philosophers of science, especially recently said, we actually do things with models. We just don't describe. We need to have an action from a model. So models are in some form endowed with this illocutionary force that you can find in Austin and Searle and the others. So it's not my intention here to do this, but I have a couple of quotes here from Woody, McCaughey, Franco. So the point is that when you look into a model, you can find this idea of there is an intention within the model, right? So some people talk about the model of an ideal gas, and I will give a little bit more about this here. In what sense a model can be intentional and can have kind of incentive to do something with the model, right? To do something with the model. Now, I intended originally to talk a lot about technology and say, hey, technology is applied science. So therefore, most scientific models are actually geared towards apply this model in science. Oh, the model of the ideal gas, use it to produce a Carnot cycle and create a combustion engine and so and so, or steam engine. But that's not my intention right now because I don't want to get too far away. It's already late. So I get some quotes here explaining for Achinstein is an illocutionary act. So that's a quote from him. Chang also said, okay, philosopher of science should change the focus from propositions to actions. So propositions are pure descriptive. Yeah, that's kind of like DN model, deductive nomological or causal models versus inaction. But I think the most literature on this will be Potocnik. And Potocnik thinks that explanations are signals that you send from a agent into a receiver. And what is the result of this? What are we targeting in this is understanding. So good. I connect now understanding and explanation because this is part of the argument. So in order to actually use a model, you try to improve, increase the understanding in a receiver. A receiver is, of course, a human being as for the time being. Okay, so the explanatory agent that created the model evaluates the interest and cognitive resources of both the agent and the receiver and the environment in which this explanation is offered, right? This Potocnik. So we have to move from more descriptive explanation into more agent-based explanations, which are actions. All right, so I have a couple of ideas here. I kind of took it apart from Franco and Potocnik, and I say something like this. You have a model and a target system, and the model has some properties. And the idea here is that when you present a model, you just don't describe it. You say to the receiver, I didn't put a receiver here, will be an R, of course. But you say, when trying to understand the target system T, you, the receiver R, you have to focus on these elements of the model. They explain T, and it will help you understand better the target system. Therefore, you have to ignore other features of the target system and focus on these properties which are modeled by our model. And the target system has potentially an infinite number of properties, but you stay focused on this. And when you stay focused on this, then you are going to understand it. All right, here, like I said, I think I need to keep this connection between explanation and understanding, kind of like Khalifa and Lipton, and not like direct. I want to keep them connected somehow because you create an explanation through the model, and that explanation will give you understanding. All right, so that's the part of the philosophy of science. I don't have but I want to say there is speech act in the process of modeling. All right. Now I want to say something about what we do as philosophers here. We interpret a lot. We create interpretations. We create philosophical models. Now, this is a pun, has nothing to do with scientific models, but we try to model the world, including the models and scientific theories and hypotheses, technological models. We are interpreting them. And some assumptions here are that LLM are open to philosophical interpretations, like we interpret everything. We interpret scientific theories, models in science, other technological artifacts, and we interpret them the way we prefer or we feel it's suitable. And one interpretation of an LLM, what is an LLM? This kind of Socratic question, what is X? Yes, pure philosophical question. One interpretation here is to say LLM are models, right? So if they are models, the question is, what is the target of the models? Now here things are a little bit shaky because you can think these are models of data, yes? The data that is fed in the pre-training phase. That's the model of the data. But things are much more complicated than that. We can think that these models, LLMs, are models of an exemplary human competent agent. Plural agents, yes. Okay, so they try to model an exemplary human competent agent, yeah. The other would be, we want to go further away from the exemplary human competent agent to some form of an ideal linguistic or rational agent, which is modeled by the LLM. Okay, these are things that it's not clarified in the literature, and different authors will go for one or the other. But I think the first one, the target is the data or the patterns in data, yes, is the most natural one. Yeah, the most commonsensical. Okay, but don't forget that the GoFi, the old style AI, was inspired by this paper of Turing from the 50s, saying that we have to learn, no, to teach the machines to learn the way humans are learning. Yeah, so that's kind of the most open-minded student of human, a most open-minded human student that can be simulated by the machine. All right, so the question that the conference is super fond of, are machines able to perform any type of speech act? And my answer will be kind of in the negative, but I do find a positive answer there. I say, yeah, no, if you interpret this and this, the LLM, or yes, if you interpret them a different way. Yes, okay, so the arguments that we heard and that are really well exposed in this conference, and I learn a lot, is that no, machines don't have intentions, LLM don't have intentions, they don't have goals, there is some missing uptake there, therefore don't expect that much speech act there. Now let's see what is the positive answer. I guess the positive answer will come once we go back to that analogy, LLM as scientific models, and let's look what is the most promising way to find that, to find the yeah, the right speech acts in LLM. So I guess, yeah, I would say, let's see what the analogy is. Okay, you have LLM and you have scientific models, and then you can think we model these based on human epistemic agents and LLM as animal agents, animal epistemic agents. Yes. Now, the C part here, I completely ignore because I don't have the time to discuss this. But the idea here will be, hey, we tried for a long time to model animal epistemic agency to say, do they have intentions, animals, right? Do they have speech acts? And if you ask that question for animals long before LLM and everything, you can look back from a scientific point of view. Let's learn some lessons from these questions we asked. Maybe we failed completely to see that. In any case, that's one of the things that kind of incited me to discuss this. So finally, the keystone, right? The keystone then closes the argument. I guess I found finally something which are speech acts in the COT, in the chain of thought. So I want to clarify something. It's not explainable AI. And as you know, what explainable AI is, transparency, opacity. We are not discussing the explananda and the explanandum as in XAI. I'm talking about something else, an explanation that comes from the LLM, and LLM explain itself. Actually, LLM explains its own result, right? That's the chain of thought. I will skip most of it. I just don't want to get into the details of what I'm trying to do here with to avoid saying that a result of the LLM is speech act. I say when you ask for a prompt for a COT, chain of thought, that prompt has a speech act in it, right? It's not the result, but it's the result, the explanation of the result. So you see, I kind of toe the chain, the speech act on a chain of thought. All right. There is a lot of new literature on the chain of thought. It's one of the most promising part of what happens now, I guess, in LLM. And I have a bunch of references to it. Most of them will say, if your prompt does not ask for step-by-step explanation, then the result in itself is worse, yes, in most of these. And examples of these are modals and conditionals reasoning. If you ask for a step-by-step, and this is in Llama, this is in Claude, this is, I tried in ChatGPT too, the results are actually improving. Yeah? So the result is not the same if you ask for a step-by-step step-by-step explanation. Okay, now, is COT an explanation? Well, explanations are like arguments, and arguments can be decomposes. They decompose this through composability. There are step-by-step, almost like a natural deduction, in which you show how you produce the result by starting with some premises or assumption, right? It's kind of a grandson system, but it's way more complex. It's not in formal language. And in that sense, I guess our advantage here is that you can play with this for even simple problems, and you see how the result is improving. Now, Holiday, Mandelkern, and Zhang explains on, I think, 24 models, right, what's going on. And here is the idea. The idea is that you have now many models available, including DeepSeek, yes, everything. You can use them. Of course, some of them are not free. And what do? You do the inference from the best code. You have the inference to the best explanation. You have the inference to the best code. Now, each code is a speech act in my interpretation because it says, pick me. I'm the best one. If you want to understand, and I put here a little example, explain to a fourth grader why number pi is not rational, pick me. I am the caught. I am the best one. The other caught will say the same. Pick me. Pick me. Yeah. So it is ultimately a speech act in the sense of if you want to understand the result, why number pi is not rational, right? Then pick me and you are going to get this result and you are going to understand it. So finally is the understanding on the receiver that is the speech act, I guess, here. So um, then what do you do as a human, right? The human is still there, the receiver. You pick the best caught. You do an IBE kind of, if caught are explanations from this plurality of models, right? Because there are different models. They are completely different models. And there is a literature about what is the best caught, but you can think about the temperature, the entropy of it, the divergence, all these elements, energy and time. If they overgeneralize or oversimplify, these are all for the best. Yeah, the best means don't trust what the model is telling you. Oh, this is the explanation. Just look at these kind of meta standards which are outside the model and decide what are the best solution. All right. Basically, if you look at this talk and you say, well, what if the analogy between scientific models and LM is not so powerful? What if caught are not explanations? What if you can do a best caught as you do inference to the best explanation? Now, inference to the best explanation has its own problems, but there are many ways in which these arguments can fail in the rebuttals part of it. Then you can ask, why did you couple explanation with understanding so strongly? We can decouple them like direct or the others. And I started to think about this today. If reinforcement learning from human feedback can complicate or simplify what I'm doing here, because this one brings human values in it and kind of value laid on the whole IBE massively, with whoever is doing the loop, the human loop, it's complicated. And I don't know enough about it, but it looks like almost all transformers have this kind of post-training RLHF. All right, good. What about transformers? Transformers don't have seriality. They are, as you know, based on attention. It's like holistic. And then you can ask, oh yeah, you want mechanistic explanations. Where do they come from if they are not coming from the transformers? All right, so that's kind of it. I guess I am kind of at the end of the rope here. Let's see what I want to say. Despite the appearances, I'm skeptical that there are normal unadulterated speech acts in LLM. But if you look at COT and when COT are there, and you treat them as explanations, then you can have a speech act, as I explained to you, this kind of pick me, I'm the best one. And then you have the human receiver who goes into the pluralistic garden of caught and picks the best caught. Okay, that's what I have to say, and that's my conclusion. And thank you for being so cooperative to the end. Thanks.
Thank you so much, Ioan. And now we move on to Q&A. Any questions in the room thus far? Let's start with one online from Alessandro, and then we move on to Ioan. Alessandro, we're all yours.
Yes, thank you. Can you hear me?
Yep.
Okay. I have a question on chain of thought specifically. As I understand it, it's like a technique of prompting that changes the whole probability distribution of which kind of token should be sampled then. So it looks to me that the role on the actual language generation is more about trying to come up to the answer rather than trying to explain post hoc, which is the answer that is given to whatever user. So I wonder if this observation makes some difference with this idea that this is like a legitimate way of talking about explanations.
Yes. I went back to the idea of mechanistic explanations when you have like a whole that is doing something and you try to decompose it to produce smaller pieces and parts. And I guess this is the main question that I put here as a rebuttal. What if these COTs are not actually explanations? What if they are not part of a reasoning and they are just post facto rationalizations, right? And the people who are seeing this improvement in the COT, they believe there are explanations, but they are working in the sense of decomposability of the reasoning, because the hope is that, first of all, the hope is that the result is not a random process. It's not pure random. If it's pure random, it's a disaster, right? And obviously you can give answers to different benchmark questions randomly, but you don't hit the mark. And then the chain of thought and chain of reasoning is then a way of decomposing it in the sense of mechanistic explainability that you have in different models. They say this part of the model will work this way, and this is the first step in it. I try to explain how kind of almost like a natural deduction, because this brings back symbolic manipulation, right? It's almost like a natural deduction. You have a symbol out, symbol in, and you want to see how do you convert or generate the output from the input. And this is my suspicion here. You see, what if COT are not explanations, but a posteriori rationalizations hard-coded in the LLM by the reinforcement learning, the human feedback? What if we impose them on the model and then they are not natural? Very good point. I don't know enough about it, but especially in the Claude, which is Anthropic, the company, they have a very serious, they put on their their it's their credo that they have to be produced. They believe that any language model should produce COT. If they don't produce COT, they are not credible.
Yeah. So the idea here is that you take this as an evidence that somewhere when you go through mechanistic interpretability inside the model, then maybe that kind of thing is going on in the circuits, right?
In the circuits, in the sense of the layers, yeah, the
Yeah,
layers.
in the sense of mechanistic interpretability, like for example, induction heads, that kind of stuff.
Yes, yes. They are statistical models, but inductive reasoning can be decomposed too. Okay, so let's think about only the causation. But if you say lung cancer and smoking, yes, you can decompose it. It's just not straight from one to the other. There are different, what happens with the cells in the lung, what happens with nicotine, what happens with the, different tissues, how the organism is not able to deal with it, and so the cancer comes out. I think Pearl is talking about this, how you write down the causal mechanism. Now, be careful, I guess. Here is the big, the big elephant in the room is causation here. And we have a problem with causation in this LLM, but COT does follow sometimes the causation. Yes, it can give you a causal story. And especially with counterfactuals, right? The counterfactuals say, if you take the cause out, then you may not obtain that. Very good. I don't have an answer to all the questions. But
okay.
Yeah.
Great, good. Thanks both. There'll be a bit more time for conversation later. And next up, Ioan. You want to come up here so folks online can hear you as well?
Yeah. Hi, thanks for the talk. So my question was actually quite similar to Alessandro, so but maybe I'll try and kind of add a little bit to it. So when you talk about chain of thought as an explanation, that suggests to me it's like an explanation of what's going on inside the model, even if it hadn't have generated that explanation, right? It's giving you some insight into how the kind of pure model is working. That's at least what the idea of it being an explanation suggests to me. But the fact that when you generate this chain of thought text, it dramatically changes the performance of the model. you get much different outputs, much better outputs. Apparently, that's why these companies seem to be relying on it. But that suggests to me that the explanation or apparent explanation is actually fundamentally changing the way the model is doing what it's doing. You know, it's generating predictions that it otherwise wouldn't have generated. So I guess there's maybe a story you could try and tell where it's both explanatory and yet the explanation, you know, kind of like economic predictions, is somehow also changing the ultimate outcome. But it becomes a more complicated picture. And then kind of two other things that I just throw in, that there have been some attempts at kind of empirical investigations to show that chain of thoughts can be kind of unfaithful to the actual goings on of the model. There's a paper which I've not read, but I've been intending to read, by Turpin and colleagues. I think it was published this year or last year. And then there's some other kind of interesting but slightly provocative work where people have tried trying to get models to generate, instead of a chain of thought, just generating essentially dots, just a whole series of dots instead of actual words. And you don't get all the performance that you do get from a genuine chain of thought, but you do get some of the performance increases relative to no chain of thought. And some people have speculated that part of the success of chain of thought might actually be just giving the model more inference speed, a more finely tuned answer. So again, that kind of casts a bit of doubt on this idea that the words are somehow giving us an insight into how the underlying model is working.
Yeah, good. Thank you. My understanding about this is limited. I played with it for a little bit, but you are totally right. The prompt that you put in, which give me some more steps, will activate different weights and different layers that you activate with the simple one. That's why the results can be radically different and for very simple problems. And so the model can completely err massively if you don't ask for these steps, and otherwise can give you a better answer to this. So yes, it will activate other patterns, and then you can ask very good question whether it's the same model, but it's actually two models here. One model which has one input, yeah, and the other model is the other input, which is step by step. So you ask two things on two models. That's why I think it's an ensemble of models. So that's why I think the idea that LLMs are not one model, it's an ensemble of models, will be very useful. And then again, you can put all of them into the IBE or COT, best COT meal, and ask which is the best one. And of course, you can find different standards for it. And one standard will be how fast it works, and definitely that will slow down. The step-by-step slows down the model massively. And then you can think about the entropy and the heat map, how much of the model is actually spiking up when you ask these questions. And if your concern is speed, then you may give up the chain of thought and take some statistical risk. They are saying, hey, well, I take a risk that the model will give me the wrong answer, but I need a very quick answer right now. And a very good point. But I have to look more into what happens when you actually ask the same question plus the COT. In what sense this is an explanation? So this is something that you can think about happening in science too. So I'm thinking you can refine a model, you can refine the type of model you are using in science, and the model will give you a different answer. Or if you want a very, very simple and quick answer, you prune the input data, the entry, and then you get a smaller answer, right? So that happens with scientific theories too. If your degrees of freedom are reduced and you work in a subspace, then your answer can be. So the idea of a subspace is that you kind of either ignore or take out some of the variables, right? Say, yeah, like in, and you just ignore the other, right? Because they are too too detailed, and then you stay with whatever you want to obtain, yes, and you take all the others as you ignore them. Very good point. I think I need to think about that. If that's the case, then explanations do depend on what's your goal, right? If you want speed, your explanation will be E1. If you want refined step-by-step result, then your explanation will be different. Yeah. Yeah. So my analogy is definitely not perfect, but very good. And I have to think about what you said about what is the source of this step-by-step. Are they already in all models and you just need to ask for it and they will come out, or yeah.
Thank you.
Great, thanks to both. Let's see if there's some more questions or comments. I have a question of my own. I'm not at all familiar with the COT literature, but I just wanted to ask some stuff about the explanation and understanding bit, because usually, right? So when correct me if I'm wrong, but if I remember this, at least roughly, when Achenstein said that explaining is a speech act, right? He characterized that as a speech act because it was answering the why question, right?
Yeah.
And so there was this kind of pragmatic approach to explanation in terms of asking and answering why questions, right? But this didn't necessarily taint or detract from the epistemic benefits that were reaped from it, right? Whereas if we're considering large language models, if falsehoods or misleading conjectures have been much more popular than the ones that track truth or track problem-solving power or other abilities, it would seem that whatever pseudo-explanations we get from an LLM would not necessarily be epistemically beneficial. Would, if it would be conducive to understanding, would be conducive to a sort of misunderstanding or to some mixed forms. And so I'm just wondering if we can import the stuff from general phil science as easily when it comes to LLMs, given that their sort of tether to the truth, so to speak, is somewhat loose, right? So what do you think?
Yes. So the pragmatism of explanation can play a major role here, and I didn't touch too much into it. But somebody like Loden and the others will say that, I simplify probably, but explanations do solve problems, right? The why question is there. I want to know why I have a problem with this. There is like an inquiry and you don't understand it. And still everything falls back onto the question of understanding. And I keep in my argument here, I keep this very, very closely connected. Therefore, like Khalifa would say, in order to actually have understanding, you need to have a veridical, factual explanation, which is true in that sense, yes? So otherwise, with bad explanation, pseudo explanations, you get misunderstanding, yes? It's this kind of like necessary and sufficient condition understanding means having a scientific explanation which is factually true and follows the scientific standards of explaining, right? Good. I think that's one answer. Now, pragmatism would say an explanation has to solve a problem. And I think Ackenstein will say that solving a problem for an action, you need to act on something. And this is what I try to avoid discussing, this kind of like applied science technology type, right? When you actually want to apply this model for something which is a problem. You have to cure cancer, right? You don't explain cancer, you want to cure it. This is the ultimate. So you don't want to explain it, you don't want to understand it, you want to cure it. Yes. Okay. And if we go that way, I stop with understanding. I stop with LLM are trying to produce this kind of incentive to the human receiver of the answer to understand what's going on. Yes. Yeah. And if that understanding, if the explanation in itself is wrong, then you don't get understanding. But what happens with the agent? Because this is the last interpretation I propose there. This can be agents. Now, if it's not a human to need to understand, but it's an action that you have to take, let's say you have like a robot, yes, it's completely autonomous, then it's not your understanding that's the final goal. It's just solving this problem, yeah. But that's connected to autonomy, and I don't want to. Did I answer your question somehow vaguely?
So the thought was, I think you have to a large extent, but I wasn't really all that concerned with a debate between realists and pragmatists or something of the sort, but rather with some key notion of epistemic success. Now, whether that is success in attaining truth, or in solving problems, or in gaining more nuanced conceptual repertoire,
Yeah.
or now, whatever the success is, it's far from clear that um, um, LLMs are geared, absent some sort of supervision or some sort of rerouting or something of the sort, or geared towards it, right? Um, and that maybe connects with this idea of sort of identifying credentials, proper sources, being able to do scientific research in a bona fide way with LLMs. So I guess the thought was, right, suppose I have, here's the way I was thinking of this. Suppose I have a very talkative friend, right? And if I wanna figure out why some historical event happened, or if I want to figure out why a certain gas tank exploded, or he's there with the explanations. Now, seldom are his explanations right? Right? Seldom do his explanations help me, solve any genuine problems, right? So this is a no-go for realists and pragmatists alike, right? But pragmatically speaking, at the level of speed check, so to speak, my friend answered the question, right? My friend produced, say, a rich explanation. And it so happens, perhaps in a reliable way, that it's false. So, are LLMs a bit like that?
Right. I guess there are like that, and they can be hallucinated on many situations where an explanation is needed, and they hallucinate on something, of course. And but remember, you as a scientist, you can pick between multiple models, and you still have multiple. Okay, so it's like a competition between different models, right? One model can be based on a wrong theory of phlogiston, the other is based on oxidation, the other is based on something else. And each model will compete to give you an explanation, right? And ultimately, you need to compare them to something which is external to the models, yes? And like in your case, the LLM will give you an explanation and you can kind of check it out as a human being with something else, with another data. Very good point. There are different ways to deal with this, but I think you still go back to philosophy of science saying, let's check the model for predictions. If explanation is so good, let's see if it can predict something. And then you say, well, I just move from explanatory models into predictive models. And if it cannot predict anything, you say, well, my standards are both. So you see, prediction and explanations are different. And both of them can be kind of part of LLM. Yeah. You can have exceptional explanations, but predictions is nullified. I have to think about that. So I didn't play so much with COT except on with Claude, and I didn't. Yeah. So the answer is I didn't play enough with it. Yeah, to give you an answer to that. But it is clear that the models can produce understanding, at least at this level, understanding of the receiver with the COT. Yeah. If that's the scope, then you stop there. The human receiver understands better what happens from the LLM.
Great, awesome. Thanks so much. I wonder if there are any questions, comments, any more rejoinders online or in the room. And if not, please join me once more in thanking Professor Muntean for his talk.
Thank you. And then we wait another 10 minutes, right?